Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we're pleased you have joined us for today's presentation, Truth or Dyne, how to properly conduct Dyne tests and what your results really mean. You may ask a question at any time during the webinar by using the GoToWebinar question tool. We'll reserve time at the end of the presentation to answer your questions. Today's webinar is also being recorded, and you'll receive access to the recording as soon as it is posted online, usually within 24 hours. For those of you not familiar with Enercon, the company was established in 1974, and we have multiple operations in the USA, Europe, and India. Our surface treating technologies are used around the world to improve surface energy for adhesion in extrusion, printing, coating, and laminating operations. Most of our audience will be familiar with today's presenter, Tom Gilbertson. Tom is Enercon's Vice President of Application Engineering and a recognized expert in the field of surface treating. He is a frequent presenter at industry events and has written numerous technical articles on the topic of corona treating. Tom is known for his practical approach to the challenges faced by converters and film extruders and will provide great insights today on the topics of surface energy and Dyne testing. Some of the topics that Tom will cover today include surface energy and corona treating, Dyne testing best practices, what your Dyne results really mean, the relationship of treatment power and Dyne level, and we'll look at other surface energy measuring methods. With that, I'll hand it over to Tom and we'll get started.
Thanks, Mark. Good morning, everybody. Thank you for joining me today. I hope you're having a great start to your day. And as Mark indicated, we're going to talk about a topic in our industry that's been discussed, well, frankly, as long as I've been in it, which has been some 38 years now. And it's still a topic that is confusing to people. So let's dive right in. So the main question that we can ask ourselves to start with is, well, okay, we're talking about Dyne testing, but let's back up a second. Why do we need to treat some of these films to begin with? You know, why? What's the reason? Well, these polymer films that we convert or that we extrude, these products all have very low energy surfaces, meaning that if you're trying to apply a liquid, whether it's an ink, an adhesive, a coating, regardless of its chemistry, whether it's solvent or UV or water-based or a 100% solids type of product, those products typically on their own with a low surface energy substrate film, they're not going to wet. And at the end of the day, corona treater's number one job is to get the surface prepared so it can wet a liquid. And so these low energy films contain things like surface contaminations, limited sites for bonding. They're really hydrophobic. They don't have any affinity to liquid at all. And on top of the fact that as they age and as they're created, many of them will have migrating additives that come to the surface of those products. So if you look at that slide that's up on the screen now, you can see that from a wetting perspective, this is not a good surface to deal with without some sort of surface treatment. So with that in mind, you know, what does a treater do? What does this corona treatment or maybe flame treatment or atmospheric plasma treatment, what do these surface treatments do to the surface? And essentially, they oxidize the film surface. They provide an oxygen component to a surface that otherwise has little or no oxygen to the surface. And at the same time, through adding and deleting electrons and just through the discharge process in and of itself, it will clean that surface, remove any of those additives that might be sitting on the surface, impeding the liquid's ability to wet. I mean, that's essentially it. And looking at it in another way, if you go to the next slide, Mark, you know, films have to be treated because if you look at it in this way, the films that we're converting all contain a certain amount of baggage to them, right? Baggage meaning they have, you know, additives, maybe there's age, maybe there's surface contamination, what have you. That all that stuff can impede the converter's step in the process. And so the corona treater now takes that baggage, sort of cleans it off the surface, and now we're able to go ahead and convert that film to something that's usable. So in this slide, and I love this slide, you know, we've been using this slide for a long time. And it's quite, in and of itself, it's quite effective. However, I would ask you to look carefully at that FTA picture on the right side of the slide that internally we call it the dog picture. And just to explain to you what we did, we have a corona treater on a flexopress at Fox Valley Technical College. And many years ago, because we kept getting this question kept coming to us. So what does a corona treater really do to the surface? I can't see it, right? You can't look at a roll of film that's sitting on your shop floor and determine just by looking at it if it's treated or not. So what we did is we took a process printed job of this photograph and we shut the treater off kind of in the middle of the printing process. And if you look carefully at it, you can tell exactly what the corona treater has done to the surface. The top portion of that picture shows the ink is fully wet and the picture looks pretty good. And the minute we shut that treater off, what happens? The ink is not wetting. And so you see the ramifications of that. Now, if you look at it in an illustrative component, look at the little image next to the left there, where you have an untreated surface like the bottom of that dog picture, and the droplet just sort of sits there. The ink droplet just doesn't go anywhere. And then once you go to the treated surface, of course, that droplet wets. So for those of you out in the audience that have always sort of, flummoxed by this a little bit, like, well, I don't understand what the corona treater is actually doing. Well, this is a great example. It's easy to understand, simple to see, and I hope it helps explain this. So, why Dynes? Well, this measurement method has been a part of our industry for as long as I've been in, and I'm sure it goes way on before me. And it's a measurement of surface energy, and it should comport with the Dyne level of your liquid. Now, in the old days, we would have these rules of thumb, which, rules of thumb are worth what they're worth. They may not be the most accurate, but they're really intended just to give you a reference point in your head, some place for you to understand. And in the day, they would say things like, well, if you should have a Dyne level that's 10 dynes or greater to get a liquid or a coating or an adhesive to wet. And, there's like a sliver of truth in there, but really what you should do is you should know what the surface energy of the liquid is that you're applying, and then match that or best that to the surface tension of the film. And here's why I'm telling this to you. And this happens all the time. Let's pick two films. We're going to pick a polyester film and we're going to pick a polypropylene film. We're going to apply watt density, a power setting, to each film that's the same. So we're going to basically treat them the same. And in one case, at the same power, the polyester film is going to get a much higher dyne number, let's say 50 dynes, wherein the polypropylene number might only get 40 dynes. And we're using the same treater, same speed, same power, same everything. So the point of this is dyne numbers will vary and the capability. So just having a blanket target and saying, hey, every film we treat's got to be, some big dyne number. It just doesn't make any sense in relationship to how the films actually respond to surface treatment. So to understand a dyne level, really you got to look at the surface energy of the substrate. We're quantifying something that we can't see. Like I said earlier, right? You can't walk up to a piece of film and determine if it's any dyne number. You have no idea. And of course, most films have a very, very low starting number, somewhere, in the low 30s or maybe even slightly lower, depending on some films. And really what the dyne level is indicating here is wettability. So, you really have to get these terms contexted in your mind. So dyne level is really indicating a wettability condition. It does not guarantee or ensure that you're going to get an adhesion benefit. Now, it is true for those of you out in the audience that have practical experience, you could say to me, well, Tom, I know that if I run this film in my printing press and I start off at 38 dynes, it's pre-treated film, and I apply so much power to it, I get the dyne level to 44, the ink looks great, and it sticks great. And that's true, that statement is true. However, we're making an assumption here that the dyne number and the adhesion value are connected. And really, the two measurements are not the same. Now, it's great that they match and that that we can go forward, make good product, and move it on to our customer. But it is the difference between those two things, and it's a difference that many people just don't understand. So there are times when you can get a high Dyne value, and yet the resultant adhesion value is not acceptable. This happens on a regular basis. Hopefully it doesn't happen to you guys out in the audience, but it does happen. And so there is not an exact science here between those two understandings. So moving forward, we're going to talk today about the different Dyne testing methods that are commonly used in our industry. Now, truthfully, and Mark, try not to laugh when I mention this. Mark and I talk about this all the time. Literally, this could be its own, we could do a multi-slide topic just on this. So I won't dive into that part of the weeds with you guys today, but I will make you aware of these different test methods and maybe ways to use them properly. At the end of the day, if you look at these various test methods, what I want you to take away from all this is consistency. We want you to choose a method that gives you the most consistency and repeatability. And we'll kind of detail this as we go down. But these two methods, Mark, 1 second, let's jump back to that previous slide for a second. There's links on the screen here or on the slides that you'll get electronically where you can actually get the actual written test methods here, and that'll be accessible to you once you get the presentation. So, and as we go on, first up is the Dyne pen method. So Dyne pens, and as many of you probably already know out there, they are probably the default method for most of us when it comes to using to doing this Dyne testing. And what they are is they're like a marker, and they have a Dyne fluid inside of them that is the right Dyne. When you pick a 35 Dyne pen, well, the solution inside is 35 Dynes, right? And the methodology there is to go ahead and use these for quick checks. They're easy to use, they're straightforward. You can stick the pen in your back pocket, kind of thing. And if you got a roll of film and you're putting it on a laminator, printing press, coating line, whatever, and you want to make sure that you're loading the roll correctly, so the treated side is the side the pre-treated side of the film is the side that you're loading. This is a great way to determine that. You just take the pen, you swipe it across the the width of the film. You take a look at it in 2 seconds. That's the time interval, right? To swipe it. You watch for the Dyne fluid to retract, and if it retracts shorter than 2 seconds, you got to go to the next lower Dyne pen, do the test again, and as long as it wets out, like in the illustration, you see the thin line and then the thicker line there. As long as it stays wet for that 2 second interval, then you know that you're pretty good. Or in the case of just, if you're just trying to determine what side of the film has been pre-treated, I mean, that's simple, right? Just take the pen. It's supposed to be 38, take a 38 pen, wipe it on the surface, and that should easily, if the film's correct, that should easily work as indicated. So these test methods have some downsides to them, these Dyne pen test methods. First of all, a lot of the films that we treat, folks, they have additives in them, and some of those additives come to the surface. So I'm thinking specifically of slip additives. Sometimes some of you may be converting like cavitated films, and the cavitation has some calcium carbonate in it, and you get slit rolls of film, and some of that powder is sitting on the surface. There may be some anti-block, other things that just happen to be sitting on the surface of that film. And as you're wiping this solution across the film, that tip is going to get contaminated. And so the more uses it gets, or for example, somebody, puts the pen down and then they don't put the cap on, it can kind of dry the tip out. Things like that affect the performance and the reliability of those pens. And so they really have a limited use, in my opinion. I would really promote the idea that the pens best are used for just determining what side of the film has been treated. If you really want to do a deep dive into, or better test method, there's a better test method really to do a better dive into the Dyne surface tension of a particular film than using a Dyne pen if that's target, if that's what you're looking to do. If you're going to use a pen, make sure you just test small areas of the film at a time. And then, like all these test methods, you're going to see this repeated throughout the presentation today. I mean, it's subject to interpretation. Now, I can tell you guys, I can have 3 Enercon people in the lab, experience, all 3 senior Enercon people, myself, and I can pick 2 other guys. We can all do a Dyne test, particularly with a pen, stand there and look at it and not necessarily come up with the same number. And, you know, we have years of experience doing this. And the reason for it is simple. The test method isn't great. I mean, if you were to redesign a test method, you probably would design it differently than this method we use today. But then furthermore, you know, if you look at the screen now, you see the Dyne values are like, you know, 5% difference. Well, 10% difference. I'm going to tell you right now, there is no way using a Dyne pen or practically any of these methods, you're going to consistently and repeatedly determine that tight of a Dyne difference, number one. Number two, I would challenge anybody in the industry that's doing, you know, typical converting type materials that we deal with, printing, coating, laminating, those sort of things, whether it's water-based solvent or UV chemistry, those products are not formulated, those liquids are not formulated to such a tight range that you have like a 42 Dyne will work and a 40 won't, or a 44 Dyne, it's got to be 44, anything below that, it's not going to wet. I mean, I don't know of any practical applications that are like that. And so, you know, limiting yourself or considering the window to be so close, that process window to be so tight, is not helping you either. So, you know, you really need to expand your horizon. And that's why early in the presentation, I mentioned to you guys, if you know what the surface energy of the liquid is, that can help you context what you actually need to go forward. So you're not just throwing darts at the wall saying, well, I think this film needs 44, I think this film needs 50, I think it needs 38. You know, there's no reason to do that. Go back to your supplier of the liquid and say, hey, how do you guys formulate this? What's the surface tension of a liquid? And they can give you something. They should be able to give you some understanding of that. So in any case, let's move forward to the next test method, which is the cotton swab method. Now, again, we have a link to this. You can get more information about this going forward. I will say that this method, again, is used. It's really kind of similar to the Dyne marker method, other than you're just taking a sterile cotton tip swab and you're applying some solution to it and you're just sort of drawing that solution across the substrate. And Mark, I think we have a video, right? We have a demonstrator video next.
Yeah, we're going to play this video. Just a reminder, there's no audio on this, and Tom, the audience won't be able to hear you while the video is playing. So we'll go ahead and play this, and we'll be right back with the audio portion. All right, Tom, we're back.
All right, awesome. Thanks, Mark. Well, that's a great video. I hope you guys enjoyed that. So let's dive a little bit into this and explain what you saw there. So in the slide, you can see that we take some Dyne solution, we apply a relatively small amount to the cotton tip swab, and we apply it to a section of the film. And then you wait 2 seconds to see if the solution either stays wet or it breaks up immediately. The benefit of this test is that it is pretty simple, right? It's not difficult. It eliminates the biggest thing it does is eliminates contamination for the applicator, right? You use it once, you take the cotton swab and you discard it, right? You don't use it again. And certainly you don't take the cotton swab and dunk it into a bottle of Dyne solution, okay? That wouldn't be good. So you just apply it as you saw it in the slide, and then in the video rather, and then you apply it as you see. Now, this is great. It does test small areas of film at the time. However, like all these tests, you do have some subjection here relative to how the person conducting the test is going to interpret it. So we're not going to get away from that with Dyne testing. There's always going to be some of the subjectivity that happens. Now, the other benefit to this that we didn't put in the slide, but I think it's a big one. And you also see this benefit illustrated down the line here as we continue. In this case, you have a comparison, right? You can have take a 40 Dyne solution in one spot, 42 Dyne solution in another spot, 44 Dyne solution in another spot as an example. You can compare them right away, one to the next. So what you're trying to do there is you're trying to minimize any conflicts, try to minimize any confusion, try to tighten up your process so that you're consistent, time to time, over and over again. So this cotton swab method is something that, at least in our lab, we use a fairly regular basis. But the test method that we use the most in the lab when we're treating film for you guys is the next one, and that's called a Meyer rod drawdown test, and we're going to touch on that right now. So basically, what this is we're using a clipboard, an object to hold the film in place that we're going to test, and we're going to apply 3 drops of solution. So let's just say our target, is 42, right? Let's pick a number here. So our initial drop might be, a 38 Dyne solution, and then let's say the middle drop is, 42 Dyne solution, and let's say the last drop is going to be a 44 Dyne solution. And we're going to take this drawdown rod and we're going to draw them all down at the same time, kind of like you see in this picture. And then we're going to have a comparison to each one right away, right in front of us. And so now let's do a little deeper dive into this test method and then see the video for this. So yeah, so some of you who have not experienced the drawdown rod, what they are, basically they are a stainless steel rod that has stainless wire of a given diameter wrapped around it. And the rod that we typically use in the lab, and that I'd recommend for those of you who want to explore this further, you just get a Meyer rod that's a number 4 or number 6. Those 2 rods work the best for this. And really all that is doing is it's drawing down the liquid smoothly and evenly. Because if you go back to the Dyne test with a cotton swab, I can tell you this: if you load up the cotton tip swab with a lot of Dyne solution, you can kind of get that to read anything, right? So you don't necessarily want to apply a ton of solution to the surface because it could potentially mess up your interpretation of the end result. So having this drawdown rod sort of eliminates, or not eliminates, but limits that opportunity. So Mark, let's run the video. So I hope all of you, thank you, Mark. I hope all of you guys saw that and you could kind of visually understand the benefit of this test method, right? Because it gives you a consistent drawdown every time. It kind of moves that solution down, and you can see visually how this happens in a much wider pattern, right? If you use a Dyne pen or even the cotton tip swab, the amount of Dyne solution you're looking at is like 1/8 of an inch or 1/16, maybe if you're lucky, 1/4 of an inch. Hard to read, right? It's hard to be consistent by just using those methods. So I like those methods previous methods simply to determine, okay, what side of the film has been treated kind of, purpose. But if you really want to get consistent Dyne requirements and readings, that let's say you have a customer that insisting that you supply them film that's at a given Dyne range, right? And you want to make sure that your test methods back up the product you're sending out the door. Well, a drawdown method with a Meyer rod is really the way to do that, because if you train your employees right and they get a little experience with this, their end result of those test methods are going to be much improved in that way for sure. The downside of that test method really is, you can't do it online, right? You can't just walk up to a roll of film and do it. So it takes a little bit of effort, right? You got to cut a piece of film off, you got to, locate it on a little clipboard. You got to be in a space where you can do this, right? And some lighting in that. So it's not as convenient as taking a pen out of your pocket and just kind of wiping the surface. But as you can see from the videos and from our, our dialogue here, it is a lot more consistent, and you're going to get better repeatable results time and time again. Now you still have operator interpretation, like I said earlier, right? That's never going to go away here. That's part of it. But I would challenge you all, give the people that are your charge to do this test, give them some time to practice this, retrain them on a regular basis, right? Because if time goes by and they haven't done a test for a bit, or maybe they're in a shift, they don't have to do it all the time, whatever reason, they need to have practiced this a little bit so that they understand what they're doing, and then the records that they generate, the recordings, the measurements they take are repeatable and consistent. So some of you might be asking, well, this sounds pretty good. I didn't know there was all these test methods and everything. So, I mean, come on, tell me what kind of Dyne levels are we needing for converting? Well, I'm an old guy and this chart doesn't help me. And some of you are probably like me and it's a little small. But I can tell you this, in general, I would say for converting processes using sort of standard converting films, and by that I mean polyesters, polypropylenes, various polyethylenes, nylon, kind of the run-of-the-mill stuff that we would use in our converting businesses and film extrusion businesses. I mean, most of our products, you can see good converting results, good wetting, good adhesion profiles generally. If you're in the, let's say, 40, 42, 44 Dyne level, it's rare that I find an application, in my experience anyway, where you require anything even near 50 Dynes or anything like that. So if you're just kind of doing the general set of converting, food packaging, general printing, all that, those sorts of things, really anywhere in the above 40 Dyne level should get you there, give or take. And I think you'll be in good shape. So really, a summary here of best practices for doing Dyne testing is really invest in acquiring the right instruction, right? So download those instructions, train your people accordingly to make sure that they're doing the testing consistently time and time again, sort of limit the pool of people that have to do the testing. The less people that you have in charge of doing this testing, you're going to exponentially increase your consistency, and your results are going to, show better consistency in those results. And then, like everything else in our process, whether we're printers, coaters, laminators, whether we're film extruders, we got to retrain people from time to time, right? Where people forget, you get new people in. Retraining on a regular basis relative to doing Dyne testing is pretty important. So on our next slide, Mark, we want to talk about the big elephant in the room here, which is Dyne levels don't guarantee adhesion. And I won't bore you with a ton of old timer stories here about how many times I've talked to somebody where their Dyne numbers are in their film are, 45, 48, some big number, and their adhesion results were not just, were not as desired. This does happen on some regular basis. And usually it's as a result of either a misunderstanding in doing the Dyne test. So basically the Dyne number that they're comparing it to, they think it's one thing, but in fact it's something else. And truthfully, the industry has not helped us in this regard because for many of you out there, you may not realize this, but we have moved as an industry less and less of these tried and true solvent-based Dyne solutions to these glycol-based or environmentally friendly based Dyne solutions that we use today. And it further to complicate that is people don't even realize what solution they get. They're not even looking at that. So they didn't even know that, number one. And then number two, the two products don't work the same on the surface of the material for the most part. And of course, if you're comparing results with this new chemistry versus the tried and true chemistry, you may not and most likely will not get similar results. So if you have historical results and then you're using this other material now to do your current testing, there's a good chance there's going to be a mismatch there. And you might think the mismatch is as a result of something in your process, an equipment adjustment, something else. And in fact, it's not. So again, I would highly suggest that you pay attention to what type of pen or solution you're buying and make sure that you're using the same chemistry on all your testing. I still find, in my personal experience, I find using the cellulose-formamide chemistry the best, the old solvent chemistry. Now, I recognize that may not be good for you for various reasons, and that's fine. But I found that if you use you stay with those, at least some of your testing, you're going to get more consistent Dyne test results. And then further to this, let's remember something: Dyne levels don't last forever, right? So you converters that are out there, you're buying film that's been blown or cast from a film extruder. It came off that extruder and through their treating system at a given Dyne number. Let's say they treated it to 40. And by the time you get it, it's at a different number, typically a lower number. Now, some of you might be asking yourself, or maybe you've even asked your supplier, hey, why don't you just treat it at 40 some Dynes, and I don't have to treat it then? I don't have to turn the treater on the press. It will eliminate a whole step here and make my life easier. Well, there's a few reasons why that can't work. Number one reason is things we talked about in the past here in this presentation. That is additives and surfactants and things that come to the surface of the film. They will themselves cause the surface energy to fall, the Dyne level to drop. Furthermore, age and time and storage conditions can cause the Dyne level to fall off. And so you collaborate with your film supplier. And a little inside secret for you converters out there, the film people can only do so much, because if they treat it too high, there's a risk on their end that when they wind this film up, it could block, meaning that it sticks to itself. You can't unwind it. So they have other process limitations potentially in their process that also limit the ability for them to provide you some outrageous Dyne number. So really the takeaway here, if you're a converter, is you use pre-treated film, take control of your process, meaning that buy quality film that's consistent from your supplier, bump treat it before you convert it, and you'll be good. You can really, again, tighten up your process and have more repeatable results. Now, with that said, what happens when it doesn't happen, right? What happens when all of a sudden you are testing Dynes and you don't get what you expected, right? Well, there's a couple of things that you can do. First of all, double check your test method. Double check the person that did the test method. Make sure it's somebody that's been trained and they know what they're doing. Maybe they have some history doing it, and kind of reconnect on that end. Test another section of the film. Was there an area of the film that wasn't treated? Meaning they forgot to turn the treater on, or maybe the treater inadvertently shut off for some reason, or something of that nature. There was some equipment disconnection. If you're only reading a couple of Dynes difference one way or another, you probably shouldn't be worried about it, because chances are they're still getting good adhesion. You're not seeing an issue like in the dog photo where the printed area or the liquid you're applying is all spotted and not wet. So don't get hung up on a couple of Dynes and start chasing that rabbit hole, because that'll take a lot of time out of your day and you're not going to net anything at the end of the day when you're done with it. Then also look at things like the treater settings. Are you running this job in a similar fashion to when you ran it the last time? Do you have historical data that helps you context these changes? And then, you know, kind of the common thing we all have to do when we see things that have changed in our processes is ask, well, what changed, right? Do we have 3 suppliers of this particular film? And the first 2 suppliers are this, you know, that worked great. We went to supplier 3, loaded that roll, and it didn't work. Well, maybe it's a film issue. Maybe the operator loaded the film wrong. You know, maybe we're trying to, you know, work on the side that wasn't pre-treated. So, you know, there are various reasons. Now, if you get to a point where you say to yourself, well, I cannot get to the end of this, I need to find out why. Here's the drop dead method to do this using a corona treater. So I'm going to give you an example here. Let's say we're running a 60-inch wide web at 500 feet a minute. And we've been running it this way all day. It runs good, no problem. Now we put a roll of film on. Based on what we know, all the equipment's the same. Nothing's changed there, but we're getting no results, right? Here's what you do. Take that line speed, run the power supply at full output. So if it's a 5 kilowatt power supply, run it at 5 kilowatts, cut the line speed in half, and then measure your dyne surface. Now here's what that's telling you. What you've done when you cut the line speed in half and you let your power supply run at full output, you've effectively doubled the size of your power supply. So if you have a 5 kilowatt and you cut the line speed in half, you essentially made it a 10 kilowatt. So if your suspicion is, I don't have enough power, it's a treater problem basically, well, you just can diagnose it pretty rapidly. So what that means is, at a double the power, at 10 kilowatts, all of a sudden you see the dyne level jump to where you want it to go. That tells you that something has changed relative to the film. And again, it might be, did we load the film wrong? Did they pull, you know, all these films look the same. They're all clear rolls of film. So did you pull the wrong roll? Is it a roll that's been sitting out in the warehouse for, you know, 6 months? So on and so forth. You kind of understand where I'm going with this. So, you know, this is a good method to determine and get you down the path to try to figure out, okay, what changed? You know, what's wrong here? And what can I do to fix it? So on this next slide, I'm going to talk to you guys about the cost of higher dyne levels. And some of you might laugh at this a little bit. How can a dyne level have a higher cost, you might ask? Well, I've had, and I'll give you an example here. I've had customers say to me, film extrusion customers say to me, I have this order for a truckload of film. The client insists that the dyne level of film's got to be 50 dynes. So I need the treater to buy a treater that's good for 50 dynes. Well, like I said earlier, I'm not telling you there isn't any, but in my practical experience, I don't know of any coating or adhesive or ink or something on a general, you know, converting application that requires 50 dynes. But if you ask your treater supplier to provide you a treater that's 50 dynes, and we do some sampling for that, you would likely find that without regard to whether it's a propylene or polyethylene substrate, things of that nature, that treater is going to be physically and economically big. Because it takes a lot of energy on some of these films to go ahead and meet that requirement. And the bigger the power supply, the bigger the treater station. And if you take it one step further, the bigger the treater station, that means you have more electrode area, you have bigger ground rolls. If the ground rolls have a coating on them, the bigger the ground roll, the more expensive the coating. You kind of get where I'm going with this. The costs exponentially keep going up. Furthermore, the equipment size, physically the size, if you're trying to place this treater on an existing coating machine or existing printing press or laminator, you may not even have the physical size to locate physical space to locate something that size, you know, on the treater, on the line rather. So, you know, there is a genuine cost to adding a dyne value that really isn't necessary. And of course, it doesn't relate to better adhesion. It really can be an enormous waste of resources in virtually every way. And in some instances where I've had practical experience here, it kind of goes like this. A few years go back, the client will come back to me and say, treater's running great, but you know, you guys gave us a 10 kilowatt power supply. I never run above 2 kilowatts. Did somebody make a mistake? And when you dig through the historical, you know, data here, what we quoted and what we supplied was based on data that we collected. And as it turns out, either the application changed and they don't need that much Dyne, or they learned themselves that Dyne value that they thought they needed isn't necessary, or they thought that, trying to get that high of a Dyne number caused other process problems in their, in their operation. So they, they kind of got themselves sorted out so that that wasn't the case, but it took them a few years to, to get to that spot. But by that time, the treater's built and they paid for it. So it's important to get this right on the front end, and to do that, you want to make sure that you look at speed and width. You want to make sure you look at, the types of films, additive loading, all those sorts of things. And with all that information, we and anybody that's building Corona treaters today, that they can all help you make sure that the treater is the correct size and therefore economically consistent. Now, there are other ways to do surface tension measurements, and Mark has put some, we're going to talk about those now. We put some slide or so in here to kind of talk about this. And there are electronic methods to determine the contact angle of a liquid on the surface of a substrate. And that substrate may be a film, or it could be a three-dimensional shape, right? And really what it's looking for is it takes a precise measured droplet, it drops it on the surface, and then it measures the spread of how that droplet reacts with the treated surface or untreated surface of the substrate. And that will give you a contact angle value. And of course, the lower the contact angle value, the more the droplets spread. And in theory, the better it should be for an ongoing process. It is very accurate. It can be used and is used as another measurement tool. I will say this to you guys. You want to use these two measurement methods discretely, meaning if you're going to do Dyne testing, that's one column. If you're going to do contact angle testing, that's another column. And those two columns don't really have a connection with one another. Now you can make a connection by saying, I get a good result on a 40 Dyne, which also gave me a contact angle of 35, and I had an adhesion value of so many, a peel adhesion number of so much, and those three columns can line up time after time after time, and that would be great. I mean, you can do that, but really the values stand on their own. And so I would encourage you, if you decide to do this, that's a great method of doing it. You're really putting yourself in a good position going forward with good process information and best practices in terms of, supporting your customer, your end user with a great product. Okay.
All right.
Thanks.
No, just to remind our audience, in the last 45 minutes, you just got close to 40 years of insights of dealing with this on a daily basis with all types of customers and every situation and application you could imagine. So really appreciate that, Tom. A quick review here before we get to your questions. Some of the highlights and must-haves. Make sure you're consistent with your Dyne testing. Make sure that you are training and retraining your employees as needed to do them consistently and properly. Always document your results, and probably add in here, don't get too concerned on a difference of a couple of Dynes. It's probably not going to make a difference in your process, considering the variability and some of the diagnostic measuring that we covered today. And then lastly, that the surface energy number that you get in terms of the Dyne level, it doesn't automatically guarantee adhesion. There's lots of other process and material factors that go into that. So keep those things in mind as you move forward here. We're going to get to your questions now. And Tom, the first question that had come up was back to the Meyer rod. How do you clean those after they're used?
That's a great question. Just use some isopropyl alcohol and a lint-free cloth.
All right. What is the best way to test lane-to-lane variation across the web in Corona treatment output?
Yeah, that's another good question. You guys are asking some great questions. Well, you could do that with a Dyne pen, right? If you draw a Dyne pen in the cross machine direction on the web, you would, if you suspect some variability there, let's say you have a segmented electrode treater and you're suspecting that a segment is not positioned properly or something of that nature, a Dyne pen, just drawing a Dyne pen across might illustrate that. You could do the same thing with the, actually with a Meyer rod too. You could also do something, it's not the most technically savvy method, but if you take a sterile cotton ball and you put some solution, drop some solution on the sheet, just kind of finger paint that solution around, and you can see when it, in 2 seconds, you'll be able to see a pattern develop if there is one, where you see variation. If you're suspecting a variation in Dyne number, you can see it appear pretty relevantly just conducting that test.
Todd, we've got a question on how can you measure materials that are absorbent that might show a false positive to Dyne testing? So on an absorbent material, any tips for trying to measure surface energy?
Yeah, none. I mean, it's kind of a fool's errand. I've had individuals over my time here kind of come up with their own method. Some people, I've seen some very clever ideas here that are used in a specific case for their specific product. So I'll give you one, like a paper product. Someone would like a paper product, and their expectation is a certain soakage of the solution. So they'll take 3 drops of different solutions. They'll drop them, like we do in the Dyne test, drop 1, 2, and 3, horizontally, and then they'll time it where the solution will soak into the product and expand or not expand, right? And of course, if the product's treated, typically the expansion is going to be greater and faster than if there's non-treatment and the bubble of the Dyne solution just sort of sits there. So I don't know that it would mean anything to everybody, but if you have a product like that, maybe you could design a test method that's specific to your need that would tell something to you. But I don't know of a universal test method for
that. And Tom, this question, I suppose it could be interpreted 2 ways. Talking about shelf life, and it says that adhesion could be required for up to 2 years from the manufacturing date. How can anybody test and predict the shelf life of the Corona? So I think there's 2 things here, maybe the life of the surface energy on a treated film, but then there may be a concern over is there a life to the bond that's created once the ink or something's applied?
Well, again, in my experience, there's no life expectancy to this because, of course, the Dyne number is not connected to adhesion, right? So once the ink, let's pick on ink, right? Once the ink has catalyzed the surface, it's grabbed the surface as it needs to, and it's dried properly, it's at the right ink film thickness, everything is cooperative in the process, and it passes the tape test or whatever adhesion test you're using in that case. You're good to go. Now, if you see a problem there, if that's an ongoing concern or you have a product that's failing, then you start a collaboration between, the chemistry of the, let's say, ink person, the film person, and the surface treatment person, and you kind of have a dialogue between all 3 to see what's going on here. What's happening, what changed, basically, right? So I think if I was in the converting business, I'm not sure that given the variabilities in our process, I would necessarily give lifetime guarantees to anything because I'm not sure how that would actually work. But I understand the premise of the question. I think really it is a collaborative effort. You look between all the relevant parties, and then of course you kind of diagnose. If you're having that problem, you kind of diagnose it from there.
Thanks for that, Tom. What types of things in or on films can cause disruption of either the application of Corona or cause the Corona treatment to dissipate more rapidly than expected?
Well, really the number one thing are blooming organics, right? So if you have slip agents, maybe some anti-blocks, maybe there's a silicone component on the surface of the film, maybe you have, let's pick on something here specific here. Let's say you're trying to treat the opposite side of a release liner product. So in other words, you have a film that's on a silicone release liner, it's wound onto itself. You're trying to treat the opposite side of the liner for a coating, let's say, or for printing, some converting operation, right? Well, if you get any offset from the silicone, because you're winding the film onto itself, you get any offset on the treated surface, well, that's going to be a problem. Silicone is not a wetting agent, it's a de-wetting agent, right? It causes things to bubble up and be slippery. So things like additives, contamination, things of that nature, which can happen in films. That's sort of, those are sort of the, the things that can cause, these occurrences.
I have a question here, Tom. Is there a risk to overtreating film? Have you seen issues from customers who have overtreated material?
And this topic I think gets a little more visibility than it actually deserves. It's hard to overtreat, a substrate. Now, as all of you who are experienced, you'll laugh when I say this to you. In our industry, there's always an exception, right? We can always find an exception, something that stuck out in your history on something, and then that, that's just part of being in the film business, I think. But I would say in a general way, Mark, it's hard to overtreat a film. Let me give you a tip or two in terms of trying to suspect. If you suspect it, here's what might be the case. Let's say you're running a film along, it's a normal job you're running, but for some reason, operations is running the power supply at a much higher rate and at a lower speed. And now all of a sudden you're having film conveyance problems, meaning you're getting wrinkles or puckers, or the film is acting strangely as it conveys through the system. You might see that if you're applying a great deal of energy to a film that's moving very slow. And furthermore, to a film that's very thin. Let's say a very thin gauge film, so there's not a lot of surface area there, and therefore the film might be getting a little warm. A lot of energy is being, taken into that film, and the reaction of the film might be one of, it's going to pucker, wrinkle, or just behave in an undesirable way. If you see things like that, maybe that's a sign of overtreatment. So go back and look at the process, make sure that everybody's operating, in the process conditions that you want them to. And then all of these power supplies for corona treaters, they're all variable. And if you see that, turn the power down. That's a simple answer here. But yeah, it's hard to, I can pick a handful of times over all these years where I've actually witnessed overtreatment causing a poor adhesion profile. It's possible, but it's not normal. It's not sort of a daily thing that you'd have to look at.
Tom, we've got two questions here on wider films. I'm going to kind of combine them. The first part is, for a wide web, what's the best way to determine the Dyne level using Dyne test solutions and swabs? And secondly, can the electronic devices be used to measure BOPP film 6,600 millimeters in width? How many measurements could determine the Dyne level?
Well, that's a great question. Let's face it, you could take that with film and you could use a contact angle device. And you could sort of, like, remember this, folks, the video we had where we kind of graded out, right, the sections where you identified like 32 dynes, 36, that kind of thing with a marker. You could probably do that at a wide film. That'd be a lot of effort. And then what you'd have to do, because you're only measuring maybe a square inch in that case with a contact angle device, you're only measuring maybe a square inch at a time, if that. It'd be tough. I'm not sure, as they used to say, the juice is worth the squeeze there. But you could do it. I think a better method, or not necessarily better, but certainly a more effective method might be, doing a drawdown test, or at a minimum a cotton swab or a marker test in sections, right? Maybe you do a third of the roll at a time or something. And what you're really looking for there is, again, a consistency. Are we if the target's 40 dynes, are we 40 dynes consistently plus or minus 10%, across the width? If you see something outrageous like, hey, this section's only 32 dynes, or this section is, 48 dynes or something like that, well, then you might look back at the equipment and say, well, did the treater shut off? Is the electrode gap off? Is it closer in one end and further away in another? There's a myriad of reasons for that to happen. And so that might, that kind of test result might lead you to look further at an equipment setup or something like that. So I guess short answer is you're probably going to use a cotton swab method and maybe do it in a sectional means.
Tom, when conducting Dyne tests, does the thickness of the film matter?
It does not.
got a question here. Let's see which one here. Okay. Um, do the electronic devices that can be used to measure surface energy, do they need to be calibrated?
I'm not able to answer that. I'm not an expert on those, and I would check back with the manufacturer of those devices. Likely, it probably has some variability with the device and the design of the, of the component. So I would just circle back with them, and they would let you know
I believe one of the companies does have a calibration service as part of their when you buy the equipment, you can send it back in, or they'll send you another one while they're calibrating. Um, there was a question regarding if you could repeat the chemistries that you recommended for the Dyne solution. You talked about both like a solvent-based and then a water-based.
Yeah, the solvent-based is the old school method. It's a combination of Cellusol and formaldehyde. Both are solvents. They're not particularly friendly solvents, meaning that, if you're going to use those chemistries, and they're still available, you can buy Dyne solutions from outside sources that formulate them that way. And they're mixed. Depending on how those two are mixed will determine the Dyne level. And further to that, if you decide to go that way, pick a vendor who is measuring the surface tension of the fluid. So here's what I'm saying to you guys. If you're buying a bottle of 38 Dyne fluid, make sure you go back to the supplier and say, do you have a test method? Are you measuring the surface energy of this Dyne fluid on a regular basis to make sure that when you bottle it, it's going to be 38 dynes plus or minus whatever their manufacturing tolerance is. And that's really what you want, right? Just because the label says it's a 38 Dyne bottle, you want to make sure that that it is. And there's going to be variability. There's a range, I'm sure that that everybody's got to account for. But that's what you want to do. You want to make sure that the supplier that you're buying these from, and by the way, it goes for
Are you there, Tom?
Oh, Mark, can you hear me?
Yep, now I can.
Okay. Same thing with pens. You want to verify with the supplier to make sure that they're testing this liquid to make sure that it is what the label says it is. Because as you guys can imagine, you don't know that. There's no way for you to tell anything. So if it's out of spec, and you're doing these measurements, you could be really, getting some wrong readings that would send you down a bunch of dead end streets, in terms of trying to troubleshoot this.
Tom, how often do you recommend retraining operators?
I mean, I would almost do it quarterly, honestly. I think it's not a hard test. It's not a lot of effort. I think doing a quarterly training and then keeping this pool of operators that are responsible to do this tight, keep it to a minimum number of people that can do it. And then, double check them, make sure quarterly that they're still doing it right, that they haven't forgotten, or that, sometimes in our industry, I've noted that we're very creative people and we can add our creativity to some of these test methods, because we're creative. And that isn't always a good thing, right? Sometimes it'll cause us to vary away from a standard. And that can, in this particular case, that can be, a pretty big detriment if it happens. So yeah, I would say quarterly isn't a bad plan.
I've got, looks like we're getting close to 11, which would be our hour time. I think we can get a couple more questions in. Do you know if the moisture content at the surface of the substrate affects the corona treatment? The person is thinking of how different substrate storage environments could affect the results.
I'm not sure about well, I guess in some way it could affect it. Here's where I'm going with this. So if you have a surface that's literally wet, meaning that you have condensation on the surface, and let's say you treated that through a metal electrode treater, you're going to get a lot of arcs and sparks, and the treater's probably going to shut off. So in that extreme example, using that type of system, the worry isn't the Dyne number, because you're not going to get treatment. On an insulated electrode system, because of the design, it'll probably treat it okay. And I don't necessarily know that, I can't recall specifically anyway, an instance where, higher humidity or something like that necessarily could be related back to a deterrence in Dyne. I mean, you might see, within the spec range, you might see a little bit of a lessening. But again, as we talked earlier, most of these formulations of liquids that we're using aren't formulated that tight, right? So even if you were up plus or minus a couple of dynes, it shouldn't really matter.
All right, Tom, one final question here. To clarify, if a film typically has a 38 to 40 dyne level, but there is some slip transferring going on, the dyne level will drop. Is that correct?
Yes. Keep in mind when we're talking surface treatment here, folks, this is literally the surface. We are talking about treaters that only affect a few angstroms depth, right? You can get the surface to change just by handling it. So take a dyne test sometime, put your thumbprint next to your dyne test, take a test again, and you'll see that where your thumbprint was, the dyne level is less. And that's from the oil from your skin. So treatment does not go through the film. It doesn't permeate the film and go to the other side or that. It's literally a surface treatment. It's treating the very surface of the substrate. So if there are contaminations or blooming agents or a downstream either roll that's got oil on it or some kind of contamination happening, you will see you may see a degradation in surface energy.
All right, Tom, thank you again. I'd like to thank our audience. If we didn't get to your question on air here, we will have somebody reach out to you. You can also reach out directly to Tom. You see his contact information here. Again, we thank you for attending today. If you enjoyed today's webinar, please send us a line, let us know. Also, if you have topics that you'd like us to cover in the future, please let us know that as well. Again, we appreciate everybody attending today. This will conclude today's webinar, and have a great day.